Hello everyone. I am doing another video on trigonometry. Trigonometry. Tri is triangle, gono is earth, metry is measurement. So the measurement of earth in the form of triangles form trigonometry. We've already done 2 lectures. Just to remind you what we had done. We had done the sexagesimal system of measurement, circular system of measurement, and we had also done the area of the sector, the length of the arc, area of the triangle, and formed by two radii and one chord. We had also done the area of another portion which was shown as shaded portion in the figure. Now today, at this time, I'm going to proceed further and talk to you about polygons. Polygons are going to be part of this also, and we are going to use trigonometrical uh, ratios in certain things. So we are going to do with convex polygon. Now let us see what convex polygon is. Convex polygon. A polygon in which none of its interior angle is obtuse. If none of interior angles are obtuse, then it is called a convex polygon. It's called a convex polygon. For example, let me draw any polygon of n number of sides. I'm not closing this polygon because I'm taking number of sides to be n. Suppose it is A1, it is A2, it is A3, it is A4, it is A5, A6, and I'll call it AN. The last side is an n-sided polygon. It is an n-sided polygon. Now we are talking also of a regular polygon. It is a regular polygon. Regular polygon. When I talk of regular polygon, that means the sides are equal. All the sides of the polygon are equal. Number one, all sides are equal. All sides are equal. All interior angles are equal. All interior angles are equal. Interior angles are equal. These things you have studied in junior classes, and you have also studied that how do we calculate the sum of interior angles of a regular polygon. It's a very simple thing which you can see, which I'll try and explain it to you just now. For example, if I have a triangle, triangle is also a polygon. Triangle is also a polygon. How many sides does it have? It has 3 sides. It has 3 sides, and sum of the interior angle of a polygon is how much? Sum of interior angles of a triangle is how much? 180 degree. Sum of interior angles of a polygon is how much? 180 degree. So how many sides does it have? 3 sides. If I write 3 minus 2 into 180, what will I get? 1 into, sorry, it's not coming here, 1 into 180, that will be 180. So suppose I take a 4-sided figure. and if I join this to this, one diagonal is joined. So what will happen is that you have two triangles now. You have two triangles. What will you get? Sum will be equal to sum of angles of two triangle. Sum of angles of one triangle is 180. So 180 plus 180, it will come out to be 360. Another way of writing it is, how many sides does it have? 4. 4 minus 2 into 180. It can have, that is 2 into 180, 360 degree. So you will realize that the number of sides increases. If the number of sides of the polygon increases, and suppose it becomes n, from n you subtract, because here 3 is the number of sides here in a triangle, 4 is the number of sides of in quadrilateral. If it is a 5-sided figure, you will see 5 minus 2 into 180, and you will get 3 into 180, that is 540. That is the sum of interior angles of a pentagon. That will come out to be the sum of interior angles of a pentagon. Similarly, if I do 6 minus 2 into 180, how many will you get? 4 into 180, 18 4s are 72, 720 degree. Similarly, 7, 8, 9, 10, whatever number of whatever may be the number of sides of the polygon, from that you can calculate the sum of interior angles of a polygon. From this we can derive a general formula that whatever the number of sides are there, from that you subtract 2. That you subtract 2 and multiply it by 180 degree, or pi radian if you want in radian, because this is in degrees. This is in degrees. Degrees can be expressed in terms of radians also. Suppose I have n-sided polygon. N-sided polygon. If I have n-sided polygon, so sum of interior angles of n-sided polygon SIDED polygon will be what? Will be n minus 2 into pi or 180, whatever you want to call it. You can call pi also, 180 also. This is the general formula for calculating the sum of interior angles of a n-sided polygon. We are generally discussing this time a regular polygon. We are discussing regular polygon, but this formula of interior angles will not apply to other polygons. If it is a concave polygon or something like that, it will not apply. Convex, it will apply. Now let us see now that what we initially started. This is basically to give you an idea which you've already done in a standard 10th or maybe in 9th, when you must have read polygons. Then all these formulas and how to calculate one angle of a polygon, one interior angle of a polygon, one interior angle of a polygon, because here the sum of interior angles of the polygon is n minus 2 into pi. It will become n minus 2 into pi and divided by number of sides. You divide it by number of sides. Whatever the sides are given, you divide it by number of sides. So we get n minus 2 into pi into divided by the total number of sides, whatever. So it's very simple to calculate how to calculate one interior angle of a polygon. This all you have done. I just thought of revising it. But I'll draw the polygon again for you, for your benefit. Let's do this. Again I'm leaving it open. A1, A2, A3, A4. These are different vertices of the polygon A5, and suppose this is AN, because n-sided polygon we are talking about. This is O is the center. What is the center of the polygon? Which is equidistant. This point will be equidistant from each and every vertices. It will be equidistant from each and every vertices. If I draw a circle, I'm talking of a regular polygon again. If I draw a circle which passes through A1, A2, A3, A4, A5, A6, A7, A8, going till AN, then the center of that circle which will circumscribe this polygon. This polygon can be circumscribed. Circumscribe in the sense that I'm taking O as the center, I am drawing a circle which is outside, which is touching every vertex of this polygon. Then it is called, that circle is circumscribing the polygon. And if I draw a circle which touches all the sides of the polygon from inside, then that is called inscribing the polygon. It is called, we are inscribing the polygon, but that is the center. The basic idea is that this is a triangle. If I drop a perpendicular here, it will become OM. Suppose I know, now please remember one thing, every vertex which is joined to this center O will bisect the interior angle. And all interior angles are equal. Suppose it is theta, so I'm saying this is theta by 2, this is theta by 2. Obviously, in case I talk of the triangle OA2M, in triangle OA2M, this is A by 2. It will divide the side also. This is A by 2, this is A by 2. If I know the side of the polygon, if I know the interior angle of the polygon, then I can calculate what? I can calculate the perpendicular dropped from O to M. Perpendicular drop from O to M. In this triangle OA to M, in triangle OA to M, OA2 is hypotenuse, OM is perpendicular, and what is this? A2M is base. So perpendicular upon base is 10 theta by 2, because the angle here is theta by 2. The angle here is theta by 2. What is the perpendicular? OM. What is the base? A by 2 is equal to 10 theta by 2. So what will I get OM as? OM will be A upon 2, 10 theta by 2. This is the length of the perpendicular dropped from, center to one of the sides, Now let us draw another and see that what do we calculate. Again I draw a polygon. Again n-sided polygon I am drawing. A1, A2, A3, A4, A5, and this is AN. And again suppose O is the center. From O, if I join this to this, and drop a perpendicular here, and take this angle as alpha by 2, so obviously it will be also alpha by 2. It will be also alpha upon 2. And this obviously is A by 2 and A by 2. Now in the previous figure, I had taken the interior angle of the polygon. Now what I'm taking the angle formed at the vertex. I have picked up one triangle because all these triangles will be the same isosceles triangle. They will be all isosceles triangles. If I join O to A4, O to A5, O to A6, O to A1, O to AN, or wherever I join, all these triangles will be isosceles triangle will be same. Their base angles will be same, and they will be forming the same angle at the center of this polygon. Center of the polygon is actually center of that circle, either which circumscribes the polygon or inscribes the polygon. So I have done this. Now in the first question, in the first description, I took the angle, I had taken angle A1, A2, A3, or A2, A3, A4. That means I had taken the interior angle of the polygon, but now I am taking the angle formed by these radii at the vertex. The same principle will apply here also. This will divide into two parts because it is an isosceles triangle. And if in an isosceles triangle, this is the basic theorem you know, if we drop a perpendicular from the vertex of an isosceles triangle to its base, it bisects the base and it also bisects the vertex. So this is alpha by 2 and alpha by 2. Now we will try and calculate two things in this. We will calculate the perpendicular in terms of alpha by 2, and we will calculate the distance OA. We will try and calculate the distance OA. The distance OA we can calculate, and the distance OM we can calculate. Now in both, this is a right angle triangle because we have dropped a perpendicular at M. Suppose I want to calculate, first thing, I want to calculate what? I want to calculate OM. I want to calculate OM. So again, OM is base, it is perpendicular, base upon perpendicular is cot theta in triangle OA2M. Base upon perpendicular is cot alpha by 2. Cot alpha by 2. What is the base? Base is OM. And what is the perpendicular? A by 2. So it is cot alpha upon 2. So OM will become equal to A by 2 cot alpha by 2. You have to mind which angle are we talking about. Which angle we are talking about. Here the angle is formed at the vertex here at O. This is not D, this is O. And earlier the angle was interior angle of the polygon. So I have calculated OM as A by 2 cot alpha by 2. Now we know one thing, that the sum of angles around point A, sum of angles around O, around any point, here it is O, is 2 pi, 360 degree or 2 pi radian. It is 2 pi radian. It is 2 pi radian. This is 2 pi radian. And it has got how many sides? This has got n side. It is an n-sided polygon. It is an n-sided polygon. It is an n-sided polygon. So the angle alpha will be 2 pi divided by n, because all these angles will be equal. Angle A2OA3, angle A2OA3, or angle A3OA4 or A4OA5, these all angles will be equal. And so to calculate them, what we do is we divide the total sum by the number of sides of the polygon. It is 2 pi by n, but I am using the angle alpha by 2. So alpha by 2 will be actually pi by n. Alpha by 2 is pi by n. And I can write OM as a upon 2 cot alpha by 2, or I can write it to be a by 2 cot pi by n, where n is the number of sides of the polygon. A is the side of the polygon, n is the number of sides of the polygon, pi in radians, you know what it is. Pi in radians, you're very well aware what it is. Is that clear? Now let us calculate the value of OA2 in the same triangle. Let me make another figure and show you again. This is any polygon of side n. I'm not joining so that I can show you the number of sides. O is again the center. From O we join A. Suppose I've joined A3 here and I've joined A4 here and I've dropped the perpendicular OM here. The angle remains the same. I'm talking of the same angle, alpha by 2. This is A by 2. The side, because it is a regular polygon, the sides will remain the same. And I need to calculate the distance OA now. What is the distance of the vertex from the center of the polygon? So in this, what are we going to do? In triangle OA3M, what am I going to write? I have this as perpendicular. I know what is perpendicular. Perpendicular upon hypotenuse. I have to calculate hypotenuse. So hypotenuse upon perpendicular is cosec theta, and this is cosec alpha by 2. It is cosec alpha by 2. So hypotenuse, which is OA3, will be equal to A by 2 into cosec alpha by 2. Is that clear? A by 2 into cosec alpha by 2, and alpha by 2 we had already calculated as pi by n. We had said that the sum of angles around point O will be 360 degree or 2 pi, and when, because the number of sides are n, so obviously n equal angles will be formed if we join each one of them with the vertices of the polygon. So I'll get n number of angles and each angle will be equal. So we will be getting A by 2 cosec alpha. Instead of alpha by 2, I'll get pi over n. So OA3 is this. Is that clear? OA3 is this. So we have got if we go to the beginning of when we started this first polygon, then we calculated what? We calculated the perpendicular drop from O to the side of the perpendicular. When the interior angle of the polygon was given, the interior angle of the polygon was given. When the interior angle of the polygon was given, then we calculated that when the angle at the center is given. Now we have taken angle at the center. Then we calculated the length of the perpendicular, which came out to be a by 2 cot pi by n, which came out to be a by 2 cot pi by n. And then we calculated the length OA3, which came out to be, I think, a by 2 cosec pi by n. Now I want to calculate, if I want to calculate the area of the triangle OA3A4. if I want to calculate the area of triangle OA3A4. You see, there will be n such triangles, and each triangle will have the same area. I have already calculated base. I already know the height. So what will be the area? Half base into height. Half base is A upon 2. And height OM. What was the height OM? It was OM was given A by 2 cot pi by n. A by 2 cot pi by n. A by 2 cot pi by n. It was given A by 2 cot pi by no. It will be not A by 2. The angle, the total base is A. Base is A, not A by 2. The base is not A by 2. Bases, the complete base is A. A by 2 is half of the base. So it will come out to be 1 by 4 A square cot pi by n. This is the area of the triangle OA3A4. This is the area of the triangle OA3A4. But if I want to calculate the area of the polygon, area of the polygon, if I want to calculate the area of the polygon, I will get what? Because this is area of one triangle and there are n such triangles. So area of the will be n into 1 upon 4 a square cot pi by n, or it will be n upon 4 a square cot pi by n. This is just the basics. This is just the basics of the polygon. This is n-sided polygon and a regular polygon. So we got the area of this polygon. We are applying actually basic trigonometry to sort out certain things which you already are aware of. The time is already exceeding the fixed time by me for a video, so I'm not going to go ahead. I'll make videos continuously for you, so that now after this I'm going to do problems based on all whatever I have discussed. I will be doing some questions. I'll pick out some questions and do it for you so that you do not have trouble. The only advantage which I want to talk about the online teaching or through the videos which we are sending is that this is all recorded and put. I'm going to put it on my YouTube. I'm going to put it on my website, Colonel Brown School website, from where you can pick it out and see again and again. A point which you don't understand can go through again and again. And the other thing is that you can always contact us. You can always contact me. This is the point which I did not understand, so that I can talk to you. I can explain it to you.